Good morning, and thank you for joining us for today's virtual showcase. My name is Colleen Bucsko. I'm your host for our breakout track, Evolution of Analytics and the Modern Data-Driven World. For session one, we are joined by Tom McManus, Technical Leader on Data and AI Platforms at IBM. Tom, welcome.
Thank you.
And from MicroStrategies, we have Juan Nunez, the leader of our Data and Analytics practice, and Bill Shay, Chief Architect of the Data and Analytics practice. Juan and Bill, thank you so much for joining us today.
Thank you.
Juan, I will now pass you the mic to get us started.
Okay, there's a mic. I didn't get a mic.
Virtually passing the mic.
Okay, all right. So thank you, everyone, and Tom and Bill for joining us today. I'm actually really pumped, really excited to talk to you folks today. You guys are very experienced in data and analytics, and I wanted to start with what you think has changed as you think about all of your experience and all of the work you have done. What are the changes that you have seen, and what really jumps at you? And Bill, do we want to start with you?
Sure. I just think back to early in my career. I remember having to write custom processes to extract data from CAD drawings in the manufacturing industry, and then to use that data to augment order entry processes and quoting processes. And now we fast forward to today, where we got data streaming from IoT devices and just automatically coming in and trying to capture it. So it's very, very interesting the amount of data today available.
Yeah, and Tom, what jumps out at you on some of the changes you've observed?
I think what I'm seeing is definitely a move from the old days of more operational and then some insightful stuff into more trying to grab insights and trying to add to the dynamicity of the business and adding value to people through AI. And I think the cloud has really added a new layer of ability to this whole data world, but it also generates more data. And how do you store it? How do you grab it? How do you deal with it? And then intermixing with the speed in which everyone expects. The customers expect things much faster. We look at something like COVID, and to coin Warren Buffett, when the tide goes out, we know who has no clothes. And there's a lot of people, like banks, really had to go out and do that Paycheck Protection Act, right? Protection plan. So how do you get that program going up if you're really locked in and that data has, where is that data? How do you get it? And it was interesting.
So Tom, thank you for that visual on the tide. But what you both are bringing up, it is like we were really focused on operations. We were really focused on collecting operational data to perhaps see how our business is performing or how our machines are performing. It just really key metrics. But Tom, you're bringing out something very interesting, which is, well, there has been an explosion of data, and now data doesn't really just sit in a nice little box. There's different streams or different ways of thinking about data. I like to think about it as there are stable situations within the business, and there are dynamic situations within the business. Now, stable situations within the business doesn't necessarily mean that it never changes. Just means that those are things that you can expect are going to happen. Like, for example, your transactional data is going to continue to come in. Certain events from devices are going to continue to come in. But then you talked, Tom, about the ability to be dynamic in the way that we interact with data, being able to go and tap into new sources, be able to consume things that are completely new or that weren't relevant yesterday and are relevant today. And I think this year we've seen a lot of that. And Bill, what are some of those things that jump at you in the difference between stable and dynamic environments and what you've seen this year and in other examples that come to you?
Like Tom was mentioning, the speed. It seems like everybody was always looking for speed. When the cell phones came, everybody saw how quickly they get data, and they wanted the same thing from their enterprise reports, right? I don't want to wait 5 seconds or 20 minutes for a report. I want it coming back in seconds, right? So then we were pushing technology like in-memory databases and trying to get data closer to off disk and things. But now we're challenged with that data is maybe sitting in a cloud software somewhere, SaaS software, and you got key data points in multiple different locations, not all inside the 4 walls. So trying to get access to that data and kind of and access isn't necessarily through SQL queries anymore. It's API calls and different ways of accessing that data, and then how you pull that all together and quickly get insights and gather insights from that new data sets. So.
And then that puts a lot of pressure on how our relationship with data, right? So is in the past we could just kind of understand where data was. It was pretty well defined, and we started building data warehouses. We started building, then we moved on to data lakes. I think we're up to data oceans and other things. But data has exploded. Tom, what are some of the misconceptions you think when we think about data and the growth and how we're tackling those problems?
I think that the way that we're thinking about stuff like this is either it's almost an all or nothing scenario. I'm seeing a lot of places, right? So I need to capture every bit of data, so that way I can grab insights. Or okay, I looked at this, it wasn't worth it. We're not capturing any of it, and there's no real way that I can say, okay, this is what I want. I don't want this. How do I deal with it? And then how do I mix that all together with my operational data that I need to grab insights out of? There's more of the static data, as Juan was talking about. How do I pull all of this stuff together and then also deal with regulations? Right. So dealing with folks over in the UK and any business there, you have GDPR. So we can't, share this, and we can't do that. And so how do I do that and then share my data, all that data that I've collected from all over the place, and share that with the data scientists, with my consumers of data. Right?
So we have this conflicting demands, right? This tension between I need speed to be able to answer the business questions, and I have the regulations that we need to pay attention to, and that really generates a level of complexity.
Especially
yeah, go
with
ahead.
more and more unstructured data coming in too, versus structured in things too. So
yeah, so yeah, go ahead.
I think the cloud itself, which was really a shift towards enabling developers. Right now I've got, or we'll call them consumers. So now I have all these consumers of my data, where in the past, or maybe currently, I have to go to IT to open up get me a new database to get to this particular data. Now I've got data spread. I've got different versions of it. How do I democratize that data? How do I do self-serve data so now my data people have that same benefit that the developers have with the cloud? And how do I spread that around without overly burdening the IT guys and speed business?
And it's kind of you're calling what you're calling out to. I think it's the need for a change in thought process, right? So Tom, in our many fun chats we've had before, you mentioned a shift from IT pipelines to self-service. And Bill, I know in your role, historically in your many roles, you have dealt with this tension between IT pipelines and being able to answer business questions. So tell us a little bit about that.
we kind of coined the term exploratory analytics around that. So really trying to look at these new data sources and see if there's any interesting data, but can't wait 6 months to model it and go through the traditional pipeline, ETL pipeline and things to find out that there's no good value coming out of the data. Like Tom was saying, is, you know, you really have to kind of have a way to kind of get the data to the end user that can understand and maybe pick out some nuggets of information from that versus going through developing traditional development chain.
But at the same time, we can't ignore the fact that there are things that need to be governed, right? And we need to be careful, because as we were starting that move towards exploratory analytics, I think one of the things that we ran into was that we were bringing data in that was somewhat related to other data within our more stable platforms. And then it just kind of generated these two worlds. I don't know, maybe we data people invented or generated the whole shadow IT world. I'm sure there are other guilty parties there, but it's complex. When you do that, you also insert a level of risk to the organization. So these were the challenges that I think this explosion in data has generated. And Tom, when we think about this move from IT pipelines to opening it up, right, and allowing others to be able to get their arms around data and work with data, but still on all of it with governance and security underneath. What are the biggest changes that you think have happened lately to be able to enable that type of approach?
Well, my feeling, and some of this has been around for a while, but it's finally kind of grabbing a little bit of traction. But you have this idea of virtualizing data. So you have existing data. So why move it if you don't have to? Take existing pipelines and place, and instead of just ending them in a location, add in some discovery into a catalog, so that your self-serve guys can go off and look up the data they're looking for. I mean, Bill was talking earlier about doing all these exploratory pipelines, waiting for ETL, et cetera. When you don't know if those $200,000, $300,000, $400,000 guys, they're sitting around for a week, twiddling their thumbs, waiting for data to come in. They could be busy, you know, and doing productive work rather than, you know, yelling at the IT guys, I need this data. So yeah, getting that data, having the ability for them to look through and search for business terms, and getting that data back in a way that they can use it, rather than, you know, having someone go in and do all that obfuscation on top of it to hide the PII and all the rest of that, is huge for those high value employees.
Yeah. And at the end of the day, why is this such a big deal, right? So, I mean, are these just people that like to play with data, and we gotta get them the data quickly so we save some money, or why is this a big deal?
Well, there is a monetary part. I mean, let's face it, we're all in business. Nobody's in this to not make a dollar, or whichever you are, wherever you are. But yeah, you know, in the end, you also need it to be able to produce or cost save. So, you know, data scientists have very interesting ways of looking at data, and it's not always the way that say myself or a business reporter may look at it. I mean, I look at a simple scenario. I'm in Pittsburgh, and we have a Blue Cross Blue Shield that bought a health center called Highmark. And they went out and they've had a data science group, but they never had access to all of the claims data as well as the clinical data. So they've always been trying to save money to the health centers by looking at clinical data. Well, they finally got into a platform. That platform allowed them to get access to the claims data. Now all of a sudden they could figure out there's certain areas that cause more deaths within hospitals, and they could see where that was coming from the claims data. So now they could turn around through machine learning, through AI, to be able to forecast when something was going, so their nurses now could stop that from happening or see it coming and react to it beforehand. So it's not always about money. Sometimes it's about saving lives and utilizing data to do that. And it's not always the traditional way. So if I were doing it and I was in a data science, I may say, well, let me look at all the clinical data and analyze the clinical data and say, oh yeah, this is where it is. But I have all the history of all the claims that were put in and the codes that were written. And now I can come out and say, oh, this is the exact path to what gets me to here. If I see X, Y, and Z, you know you're going a bad path and you need to correct. So it can save lives, it can save money. It's you know, there's a lot that can be done with data science.
So there's value within the data, and we need to ease the way in which we get to it. We interact with it, we analyze it, we gain insights, and also we gain the ability to influence our own business processes. So that's spot on. I think it's very important to understand that even though there's these growing complexities in data, there has been approaches there are approaches that have been available to us for a long time. Like data federation came up like 20 years ago, and now you're talking about data virtualization, which is federation on steroids. It actually works now. We couldn't do it back then because we didn't have the cloud capabilities that we do today, or no, we couldn't do it as well. So you both are talking about the growth in complexity and the need for this stream pipeline in which we take data from its most granular state to insights we can take back to the business. And we have a little treat today, Tom. We're gonna walk through some actual examples and just kind of take a look at Cloud Paks for Data, IBM's Cloud Paks for Data. And you're as you start sharing your screen, and as an introduction, Bill and I, along with Tom, in the problems that we're trying to solve, we look for how do we bring this together? How do we turn these IT pipelines of old into a place where people can go, and the users, whether they're analysts, data scientists, data engineers, they can go and collaborate in a pipeline of events that take the data from that granular state all the way to valuable business outcomes. And Tom, why don't you help us with what we're looking at real quick?
Okay, I just want to make sure that we are seeing this. This is the, I've changed the name to the MicroStrategies Data Platform by IBM, but this is actually called Cloud Pak for Data. But it's a basic common UI for doing different data projects, and just for it's a Kubernetes-based data platform that allows you to pull in many different services that you may or may not desire to have, right? So it's not a one-size-fits-all. It's not a buy-all. It's a take what you're looking for and utilize it. So in this case, we're looking, I'm going to filter on the ones that are enabled and started. We're going to do a little demo with Watson Studio along with machine learning. I'll show you a little bit of data refinery. Some of the, I'm not going to show it, but I'll quickly show you some of the Watson Knowledge Catalog. But we have data virtualization and DB2 warehouse. And what I'm going to do is show you off how to do something called Auto AI. And where Auto AI fits into this whole space is it really tries to give you the ability to have a citizen data scientist. Okay, so what is that? So a citizen data scientist is a person who has some data science skills, but not the true propeller head, right? So not that person who who's studied data science for in college as a PhD in data science, and maybe has been trying to write algorithms, right? So this is someone who's looking at data and knows where they want to go with it, and they want to build machine learning models in an automated way and get started, and then go through the different ways of doing this, the different code, and say, okay, I can tweak this here and I can tweak that here, but here's a really good starting spot, right? So what I have here are a few of them that have gone by. So let me just click on the experiment. I'll show you what it looks like in the end while we're working through it. So essentially what we're going to do is grab a set of data, and then we're going to select what we want to take a look at, right? And what outcome we want to get. And then we want to let the machine learning tasks go through and build pipelines and build feature enhancements and do those things that those data scientists do, but this is going to do it in a pipeline for you. So in this case, I've already run one. It's came out with 12 pipelines across the board. It didn't take very long to do. In this case, we took 85% of the training data in it. 15% was considered holdout data, so that we could go back and test the data. And this is all part of that pipeline process. So we pick the top classifiers: random forest, XGB, and in this case, decision tree. And then it runs through all these different ways. So these guys went through these different pipelines and came out with different feature transformations. And ultimately, this is the one that followed through to do the best and come up with the most accuracy. So we come down to the bottom here, and we see out of all these 12 pipelines that ran, and you can change those, that pipeline number 8, which was an XGB classifier and a couple of enhancements over here, was the right one, or the best output. That whole build time was 4 minutes, so you can come through and do a quick calculation that the whole elapsed time was probably 10-15 minutes, which we'll run through one of these. But you can see the cross-score validation, the holdout scores based on the evaluation. We can drill in to this pipeline, and for those, the model accuracy is about 98% based on this classifier. We look at the true positives and the true negatives versus the false positives here and the false negatives, and you can see how accurately you've predicted and where you are. Now, why would you do this? This happens to be a bank marketing data set where they went out and tried to sell certificates of deposit. Probably not the best thing to do when you have 0% interest rates, and you're not going to get the best response. But this was a marketing campaign that came out. So based on that data, which I'll go back and show you that, you can figure out who your targets are. So this is a go ahead, Juan.
So, yes, if I can jump in, one of the key things that we look at here, and I think it's important to highlight, even in an organization where you do have data scientists, there's a priority list. There's a slew of items that data scientists need to be looking at, right? And what this could actually do for a data science team is to be able to run through some of the initial thinking process that they go through. So this is not going to replace a data scientist at all, but it can definitely go through a process where different approaches are tried. You get the results from those different approaches, from the confusion matrix, for example, in all of these outputs you can leverage in different ways, but confusion matrix, for example, you actually leverage that right out of the box to figure out the cost of these errors, right? When you're looking at false positives or false negatives, whether these models are getting us closer to where we need to be. organizations that don't have access to data scientists may very well, by looking at this and analyzing that, for example, it makes sense to launch this into a process or test it alongside of a human-driven process. You get an acceleration. Now, a data scientist is definitely going to be able to take this much further, right? So this model is 89% accuracy in the sample that we looked at. But you also need to look at this and say, is this along the lines of what would make sense from a business perspective? And there's some cases where you really can have no tolerance for false positives or no tolerance for false negatives. And as you are creating this, you can actually go back into these models and tweak hyperparameters to adjust for that. Now, it is not a replacement to a data scientist, but definitely gets us going much more quickly into that direction. And you talked about this being a matter of minutes. You started from the data, right? And you started cleaning up and getting the data ready for it. So how do I think? I want to ask you a couple of questions. So one is, I have data in all over the place, right? In many places. So with this, what benefits do I get from having this? And how do you think about that data that is in many places that then I bring in to build my models?
So when I'm looking at when I'm in a project, I'm pretty much going to start out with no data assets to start with that I know of, unless I have a spreadsheet that's local, a CSV file, which people tend to have. It may be that I want to look out and say, okay, what's in my catalog? What kind of marketing data is out in my catalog? And maybe this is a database. I want to add this in here. And it gets added to the project, and then the connection gets added in here. So this is my marketing data. This is the data, the access to the database. And I don't remember if I profiled this or not, and we'll see. We did profile the data to figure out. I forgot if I had or not. To figure out where how accuracy, what's the frequency, what are the statistics of all the data that's in this particular data source. What are the types? Is this the data that I'm really looking for? And then, is this readable? What is this Y thing? So when you go off and you take a look at Y, and if I truly categorized all of it, I'd be able to look at all of this and say, okay, this was the success criteria of the promotion. So maybe I want to change that because I want to add that in there. And so I can go and refine this particular set of data and build a new CSV. If this connection was used in something, it would show up in here. Right now, it's only been published to an athlete, so we don't have a lot of lineage in here. But it would be added if it was in an ETL project or wherever else, so that we knew the process that it got to get here. In the scenario of this, and say I wanted to change that value, and I could go refine this data, which would bring up a data refinery, which will allow you to do some quick adjustments. Okay, maybe not as quick as I want to, as usual.
It's kind of your cleansing stuff, your preparation, data prep stuff.
Yep. And ultimately, I'll go to the result here, which should be doing the same thing, which is going to show the flow. And all I did was change the Y to something more valuable. But you have the ability to take a step and create a job, and no matter what you do when you do run live, it always seems to screw up. But you have the ability in here to do joins. You can do math. You can do all kinds of cleansing in here. In my case, I went and changed that Y to a promotion, and it'll show you the 2 steps that you go through and do it, and then you can execute it. You can save it and execute a job. So this is a refinery job that you can run against any data connection. So I can take that connection I showed you earlier, I can refine it, and then it gets saved off into, in my case, the shaped output, so that I could then use that in my auto AI model, which happened to be here. And this is the new transformed piece that actually has that in there. Now, very rudimentary refining, but that's, things that you can do within the refining piece. So I can take the data, I go look it up in the catalog, I pull it up, I see what it's there, I profile it to see what the statistics look like. Is this data worth anything? Is there any quality to it? And from it, do I need to shape and change that as a data person before I go run my experiments? When I go do an experiment, I put in my Juan experiment. I can change how much I can run against it, see how fast and how the larger the data set and the more complicated, the more you want it, more power you're going to go to it.
So before you leave that part, actually it's all good. So just thinking about that piece that you just went through, this being a containerized environment, right? And a lot of our conversations today are around the cloud and how infrastructure aligns with these solutions. We do have, in this scenario, we do have, for example, the ability to say, I am going to go and provision some GPUs that I want to use to run these highly complex models, and then be able to run our models and our model training in those GPUs. And once I'm done, I can turn them off. And just the ability to be able to do that, being able to do that, it's a huge impact on cost, on reduction of cost, as opposed to actually having to have all of these things online at all times to use it. And it is one of the benefits of being able to select how am I going to run this particular experiment, which I think is it's more in line how we want to use cloud.
On the flip side too, it would allow you to maybe run experiments that maybe you wouldn't have had the horsepower to do because you wouldn't have invested in that horsepower to sit there dormant for a while. But you want to run some experiments that you can ramp up and then ramp down. So.
And also in that same vein, as I showed earlier, this is 1, 2, 3, 4 products that are pulled together that are one, right? They're really services. So in the world of cloud services, you've pulled these together into one UI that you can govern by persona. So if you have someone who's just a data engineer, they're not really going to see the Watson Studio components. If you have someone who's just an analyst, they're not going to see different components to make it confusing. But it's one platform UI that the line of business, the company, depending on the size, can use, all within the same data set.
So Tom, so this area, right, where you have the services in the catalog. So let's say I'm an IBM customer. I already have Cognos. I already have SPSS or Data Stage, and I'm trying to figure out, okay, do I just keep those individual tools? How does it all come together? Can I actually use those things that I already have and connect them to this?
Sure. For the most part, I mean, I'm my view on utilizing this is so let's say you're a Cognos customer, which is there's a fair share of those. They also have folks that are using Tableau and other tools of that nature that can connect into this this platform and this data plane. So you have different ways of doing it. But if you have Cognos, my suggestion is not off the bat, saying, okay, we're going to go all in on this platform. But I would look at use cases that are new to go off and build on the platform and build out the platform and get usage out of the platform instead of doing my quote unquote migration, right? I don't want an outage of what I already have, but let's look at some new project that we can go pull in and utilize this particular capacity on the platform, utilizing the different pieces of data. So yes, you could lift and shift those up there. And I'm not saying that you shouldn't, but I don't think I would start there. I would start with a new project and get the success out of the new project, and then go look at, okay, where can I onboard more folks after I'm feeling successful. I'm not a big fan of ripping and replacing without success.
Right, you can gradually move into it, but but the experiences and the skills that you have in whether it's SPSS or data stage or some of the other components, you can bring them into here. And if you're a type of user that is going to access those capabilities, you actually have a simplified and more streamlined process to go from your data to the applications that you're going to use. Before I stopped you, you were going to go a bit more into I think the projects and how all of that comes together.
Yeah. So based on what you're saying, so we're in the same space again, right? This is an analytics project. So just creating one is new project. Pick the one you have, and let's say you're a data stage user and you want to pull that in too, right? That would actually give you a transformation project. So you can utilize things in projects that allow you to store them in your GitLab, GitHub, whichever repository you have, so you have a backup of all of that. And then you would create that new project. It would give you the similar look and feel. This is a transformation project. Just happen to be winging this one here. It's probably not the right. If you want one, you're probably going, no, don't go down the road. We only have so much time. But you can see it's slightly different. But this gives you the project of the way that it's very similar with data assets and rules, but it gives you a project in which you can work in and feel comfortable in. So let me go back to the project I was in.
I do like that you're able to do this all from the same interface and jump between the types of different technologies and different products.
Yeah, and as long as you have the ACLs to get there, you're good to go. So let's see, where was I? So we were going to go down this AI project, and I started it, and I said, we go down to, so I'm going to select the shaped version, right? Because I already went through, I did my data refinery, I shaped that off. And then I look at all these different columns here, which one do I want? And I want promotion accepted in this case. I happen to know that. It picks, based on the data that it looks through, it says, okay, binary classification is probably the right one. I want a positive is yes. And then we're going to look at the accuracy as the optimized metric. Now, maybe you're smarter than this tool, so I can go change this, right? So I only want to sample. I'm going to do a subsample of the rows, because I don't want to do all of them. I can do 80% of those rows I would have done, or I can pick a number. I'm not going to do that. I'm going to leave that as is. If I want to reduce and say, you know what, I don't think default is or the type of house matters if you're going to buy a CD, then you take those out, and so you can modify that. Based on prediction, you can also do the same thing with prediction. It's binary because it's primarily yes and no. If there was something where you needed a multi-class classification, you can do that. And if it was set up based on the way everything was set up with Booleans, or whichever, you could do a regression analysis on it. You can change the class. So if you want to run it as no, then you can do the confusion matrix based on no. If I want to change which optimized metric I want, it's there. These are the algorithms it's going to choose from. I can say I only want to do one algorithm, right? Not only test 2 of them, or I want to test 4 of them, which is going to generate you 16 pipelines. So you can pick and choose and adapt the way you want to do it, and then how much compute you want to run against it. This would be the setting of that, of there. And then ultimately, once you're content with it, you're going to click run, and it's going to go off and generate that pipeline that I already showed you. And generally, the how is not as exciting as the why, and I don't know if the ending, but this will show you, what's happening with it and what it's doing. It's walking through the different aspects of what's happening, and it will slowly build out those pipelines. Mm-hmm. So what I already showed you what the outcome would look like, but let me go back to this one here. We decided that this was going to be the one we chose. It was the best. But in this case, I'm going to save this off as a Jupyter notebook if I wanted to, and go take a look at the code that I would use, or the model. So let's just say we did the model. We can change the name of it, but I'll leave it as is. Put a description in. It goes off and saves that off. We can go view that in that same project. And this is the input and the output. And if I want to, I can go off and promote this to a deployment space. Now, a deployment space is an area which is essentially taking this from the development area out into an area where we want to deploy this for usage. Mm-hmm. So this sometimes would be where you get the handoff into a production space or into a test space. Then I can click over here to go to the deployment area as soon as it does that. And I won't enlarge one. But essentially, from here is where I'm going to go deploy this out into the production. In this case, I already have one, so I'm going to use it. I can edit the configuration. I can replace it. But once I look at it, this is the endpoint that all of your applications would access. So if you were going to build this model into the way your call centers were going to go out and do outbound calls, you would be using this and adding this in and say, okay, is my candidate, or maybe it's an inbound call, is this candidate someone who might buy a CD? Might they take a CD promotion?
Yeah. And
as your customers or customer service folks are talking with a customer, you can pop this up if they look like they're going to be a good candidate. So based on our machine learning, we've got a 90% chance that they would be interested in a CD promotion based on the 98-point X.
Tom, so one of the things that jumps at me, one of the things that jumps at me is how much effort I and my teams have gone through historically to go through the steps that you just walked through. And of course, there's a lot of validation that occurs, and there's much more work that goes into it. But just the following the steps to a migration, that can be quite complex when you're trying to do those things and migrating objects and maintaining versions, and it's all built into this. The other point I would want to bring up is that in this case, we generated this model with a auto AI, but you could actually do that with any other models, right? So if you went and used SPSS to create your model and just create it as an object, you can treat it the same way. And I'm actually quite giddy and happy as a data guy thinking about the possibility of going from data all the way to a production environment. And yes, there's a lot of work that goes in between, but it's simplified some of the key aspects of our work that that can be quite heavy on the time to market.
Yeah, remember I spoke of Highmark earlier. They had their own data science team. They had their own open source tools. They were using Jupyter notebooks, and they had a version of machine learning that they were trying to do. Their DevOps cycle was somewhere along the lines of 6 months. The project they did for the health system, and the IBM data science elite team helped out on this to get them through this on this platform was 6 weeks.
Mm-hmm.
They went from concept to data import to governance to modeling to testing to adapting to testing, an iterative process out to deploy to the beta to the essential nursing staff was literally in 6 weeks. So
yeah, and it's like it's the friction that when you're dealing with silos systems and the output from a system and then shaping that output from a system to be able to work into another, so on and so forth, that introduces a lot of complexity. I'm sorry, Bill, I cut you off.
No, I was going to say the same thing. I agree with that. Yeah.
All right, so we have our model deployed, and if we can touch on something, thinking about the different roles, right? So we're talking about data scientists. This looks like data analysts and data scientists have a way to get to capabilities very, very quickly. But tell me about the administrator that is sitting on the background here, typing away with every click the users are making. How do they keep up?
Well, the nice thing with the platform, and I will say that the version that will be released November 20th will have more administrative capabilities. But you have the ability to manage a platform right from the actual UI. So the administrator themselves, let me go back. The administrator themselves has obviously the ability to change the custom branding, so you can change it to whatever you want. You can create users. This can be pulled in. You can use LDAPs, SAML, etc. In 3.5, you can utilize groups to manage all these. Here are the different roles in which we build pre-canned. So if you have a developer role, there's a data steward role, and each one of those roles have different permissions that allow you to do that. You notice that many of them have access to catalogs. Some only have the ability to create service instances. Some only have access to catalogs. So depending on the role in which you are, you can control what people have access to. Now you can group them now. So if there are a group of data scientists, you would apply that data scientist to every one of the services. And now anyone who comes into the data science role, you've now controlled their access.
If I could jump in on one part too, one thing I really liked about some of the administration tasks is, like you were showing how you can easily create a Jupyter notebook and do a lot of the Java code from a data science aspect. I like the spot where you can create a remote listener or a transmitter to deploy on a, say, Linux system that's going to send log data or specific cherry pick specific items. It actually builds out the script and to communicate back from home to this area, and you don't have to manually do that. You just put in a few items and configuration items, and it builds a script. You kick the script over and you deploy it, and on the remote system, and now you're connected. So it's really an interesting way to do it all from this interface. And the other piece that goes along with that kind of is, I like how easy it is to go in and view logs in here to see when you have some trouble, when you're trying to do some troubleshooting of that too. It's very, very interesting, all in the same environment. So
yeah, it's just some of the stuff you're talking about is around the data virtualization piece, which again, I didn't set up a whole lot of it today because I thought I only had about 15 minutes. So, but it, you can connect, in theory, as long as you have all your firewalls open and everything else off to AWS or Azure, the data sets that are over there. And as Bill was saying, there's a little script that allows you to put in an agent over there. So you do the work over there. So you don't incur the egress costs of sucking the data out of those environments. So there is a lot of interesting things that happen with data virtualization, because we can go do some of those the heavy work where the data is, and we're only pulling back out the subset of that data out of remote data sources. Whether that be in a cloud object store or literally someone's desktop, which kind of scary that may be the way it is, but there's SharePoint, and then there's people who have shared file directories, and where they stick all the CSV files. It's historical.
Why didn't the data load? Well, someone cleaning lady turned the desktop off.
And it's scary, but reality. I mean, I listen to my wife where she is, and they run by spreadsheets.
And so I think that as you were talking about being able to access data in many different places, I think it's very, very important to understand that, and I love the term that is used in this platform around data constellations. There's data all over the place, and being able to understand where those data elements are, then allows us to say, all right, so now I have access to this data, I can go discover it. And as a business user, the limits are removed, right? So I can go explore it, I can understand it, I can take some samples of that data, assess their value, and then ultimately bring it back to, all right, so we'll need a more stable process to consume this data. But I already was able to explore and get value from that data very, very quickly, as opposed to
and getting an understanding where it's coming from too, right? And things.
Yeah. So the lineage and the governance pieces. So there's so much to cover here, and I recognize that we're not covering all of it. I think that what we'll offer up to those who are with us today or watch this in the future is we'd be happy to jump in and go through these items with you and answer any additional questions. When I saw the first times, I had 1,000 questions coming from it. But I think what we want to leave this part with is the simplification of the entirety of the process, right? Being able to tap into the data, tag it, secure it, analyze it, build machine learning models that build visualizations with it to share with the organization, and then ultimately get to the value of it. I think we're kind of close to the time, and I wanted to just take an opportunity to close out with some general thoughts from you guys. And if you want, Tom, you stop sharing so we can see your beautiful smiles a lot better. But if I could ask you, both Bill, Tom, as you think about how things have changed, and we've been talking about the changes, we just went through something that makes it really easy for us to interact with data. What are some of the key thoughts in your mind that you would leave with those who are trying to solve these challenges out there in the field? What are some of the key thoughts you would leave with them? One at a time.
So for me, I mean, we if you've dealt with IBM at all, we've pounded the table on this concept of an AI ladder, right? And there's no AI without you know the information architecture. The two aspects of it, and I think almost any almost any solution you can do data science, and almost any solution, you know, you can do some of all of it. But one of the things that I've found nice about the platform is that it has what you need in it. And it allows the people who are doing the work to utilize the tools in which they're used to using within a common UI. And I started playing around with it, and maybe I got, you know, off and playing around too much. But if we went off and looked at any of the access to the SQL editors, they're all the same. So whether you're on DB2, Mongo, the SQL editor is the same across the platform. So you're not like you need to learn a different tool, a different space for every tool. So maybe I'm thinking a little more holistically around or myopically around the IBM tool and the platform and what you're thinking. But I'm also giving Bill some time to think. But no,
and I was going to come to a different aspect. I mean, you really need to get, I think, data closer to the end user sooner, right? And one way to do that is to reduce complexity of getting to the data, which this unified platform does help with. So it's really trying to get buy-in and actually maybe even have them curate and bless the data so that other people aren't afraid of using it or things like that. So I definitely, from you know, just kind of a process, not tool agnostic view, it's really, I think, getting the consumers closer to the raw data as possible, as close to the raw data as possible, quickly as possible. So.
Yeah, and you know, I think that's a great point, because as you look at being able to tap directly into these operational systems, and you move that data and are able to prepare that data and build models off of it. Now we are in a situation where we could deploy AI and machine learning processes, models, back down to those operational systems so they can actually live within them and enhance them in a way that we couldn't really do before, or it was really challenging to do before. And it's critical to recognize the friction in these siloed systems that's been collapsed with this type of approach. And I think we are welcoming Colleen back because she's about to kick us out.
Yes, I hate to say it, but we've reached the end of our time for this session. So thank you, gentlemen, for joining me and participating in the conversation. And as we transition into session 2, I just want to say thank you so much to Tom McManus from IBM for joining us. If you'd like to connect with Tom, we will have his information following this session and also in the post-event follow-ups. So you can connect directly with Tom. Tom, thank you so much. Have a great rest of your day.
Thank you,
You're
Tom.
welcome. Thanks for having me.